Hello student friends, welcome to this video lecture series on digital techniques. In the last lecture we had discussed about this DEMUX tree, right? How we can implement a higher output DEMUX with a lower output DEMUX, that is 1:8 can be implemented with help of 1:4 or 1:2. Alright, now here in today's this video lecture we are looking for implementation of combinational logic circuit using DEMUX. This concept we have also seen for multiplexer, that how a given logical expression can be implemented with help of multiplexer, right? Now here we are going to use demultiplexer. Okay, so let us directly jump on the question. The question is implement the following functions using DEMUX. Now here one function is given, two functions are given. Okay, and this was asked in one of the diploma MSBT examination for 4 marks. Right, so let us try to solve this and try to implement this function or combinational logic circuit with help of demultiplexer. Now here again, looking at the higher number, you can see this higher number. Now here literals are not mentioned. Okay, so you have to look for the highest number in given equation, that is 6, and from this we can understand that it is 3 input variable. 3 input variable this equation, right? And for 3 input variable we need to use 1:8 DEMUX, because 1:8 DEMUX will have 3 select lines, right? So it is again very simple, nothing hard or nothing very much complicated in this. Actually what you have to do is consider this equation and you can simply draw the 1:8 DEMUX. So this is 1:8, one input, that is D in, and we have 8 outputs. So 0, 1, 2, 3, 4, 5, 6, 7. These are 8 outputs. You can simply name them as Y0, Y1, Y2, Y3, Y4, Y5, Y6 and Y7. Okay, then you need to have 3 select lines. So this is S0, S1, S2. Okay, you can just simply give the names of literals A, B and C. Now looking at this function, f of f1 is equal to summation of small m. Now this small m corresponds to SOP, and SOP corresponds to binary 1, right? So I will just capture, or I will just take these numbers. So it is 0, 2, 4, 6. All these I need to connect to OR gate. Okay, so this is function F1. Right, now if you provide specific this binary numbers here, then you will get output as 1 here, because this is SOP. Okay, and the second equation we have here as 1, 3 and 5. Now you can take that 1, 3 and 5 in this DEMUX itself, or you can you can draw another DEMUX and consider this function in that second DEMUX. But I can even take this here also. So this is 1, 3 and 5. Okay, I'll just extend this. I can connect these to OR. This is F2. Okay, so this is for F1 and this is for F2. Okay, so this is actually the solution or answer for implementing this given function with help of DEMUX. Okay, so as I said, very easy it is. Nothing complicated in this type of questions. Okay, let us go for another question, that is implement full subtractor using DEMUX. Right, now you need to recall the concepts of full subtractor, because here it is not mentioned which DEMUX we are supposed to use. The question is simply implement full subtractor using DEMUX, but simply correlating the concepts. Now full subtractor has 3 inputs, 2 outputs, right, and this DEMUX has we have to see which DEMUX has 3 select lines, because for DEMUX that select lines we provide that input. Okay, so it is again 1:8. Okay, so here one thing is clear, that for full subtractor or maybe for full adder we go for this 1:8 DEMUX or even 8:1 multiplexer, because it has 3 select lines. Okay, here we can see for full subtractor, and then you can try for full adder. Now since we need to complete, or we need to recall the truth table of full subtractor, right? So I have given here these inputs, and with pencil I have written this, so we'll just recreate or recall or revise these concepts. So 0 minus 0, difference is 0, borrow is also 0, right? 0 minus 0 and 0 minus 0. Now for second case, 0 minus 0, difference is 0, 0 minus 1, difference is 1, borrow is 1, right? So 0 minus 1, difference is 1, borrow is 1, and 1 minus 0, difference is 1. 0 minus 1, difference is 1, borrow is 1, 1 minus 1, difference is 0. 1 minus 0, difference is 0, difference is 1, okay, 1 minus 0, this is 0. Now 1 minus 0, difference is 1, borrow is 0, and 1 minus 1, again difference is 0, borrow is 0. 1 minus 1, 0, 0. Now here 1 minus 1, it is 0, difference is 0, 0 minus 1, difference is 1, borrow is 1. Okay, now here you need to form that equation for difference and for borrow. Just we have seen in the previous example that we had two that expressions, and using that expression with help of demultiplexer we constructed that circuit, right? So here if you want to form the expression for this demultiplexer, you can simply number this. So it is 0, 1, 2, 3, 4, 5, 6, 7, right? Now here if we consider this column, the difference column, now what binary what decimal number corresponds to binary 1? It is 1, 2, 4, 7. You can see 1, 2, 4, 7. and for borrow, if you consider this column, then it is 1 2 3 7. Okay, now here we have these two expressions, right, and we can implement that with help of this demultiplexer. Okay, so I can just write down y of d summation of small m 1 2 4 7, and y of borrow, we can say borrow out, equal to summation of small m 1 2 3 7. Now with help of this equation, we can simply implement this full subtractor with help of DEMUX. Now it is 1. Okay, so 1 2 4 and 7. Okay, so I'll just draw this OR gate here. So I can take 1 2 4 and 7. So this is for y of d. Now for this borrow out, again I'll simply draw here first. This OR gate, and I can just extend this line. It is 1 2 then 3 and 7. So this is for y of borrow out, right? So this is the solution, and here now we can give this a, b and c is borrow in, since it is full subtractor, borrow in. Okay, so this is the solution or answer for this question. Implement full subtractor using DEMUX. Similarly, you can try to implement, say, half adder and full adder using DEMUX. You can try these two combinational circuits with help of DEMUX, right? So this is all about demultiplexer. Now we have covered adders, subtractors, multiplexers and demultiplexers. So in the next lecture we can actually go for this encoders and decoders. So two types of encoders we are going to see, that is BCD encoder and gray code encoder. Okay, so in the next lecture we'll see all the details about these encoders. Till then, have a nice time. Thank you.